Hi, everybody. I just wanted to make a brief video about the second half of 1.3. We already talked about 1.3 a little bit in class, and we talked about, the equations for a line, the two equations that we're going to be dealing with, point slope and slope-intercept form. I showed you how to work that in your calculator so that you can use that as well if you need to. But now what I'm going to do is just run through an example. It's almost identical to one of the ones that you see in the book. It's not the exact same one, so you can still use the one in the book if you need to. But it's just another way that you can work through and see what you're doing. So that being said, let's not waste too much time. We'll get right back to it. I will share my screen so that you can see exactly what we're talking about. But for the main part that we're really thinking about here, this is section 1.3, and this is about lines of best fit. I'm not going to call them lines of best fit. I grew up calling them best fit lines, so that's just what we're going to be dealing with. The ways that you work with best fit lines, first you start out with a scatter plot, and we're going to talk more about scatter plots in a second, but you start out with a scatter plot. We are going to have a bunch of different data entries. You take those data entries and you use them as points and you put them on a plot. You then see if they have a correlation, if they're going in the same direction, if they're not going in the same direction, if they're going in a positive or a negative direction. We'll be able to tell a lot of information from that. But we'll get there in just a second. In order to create a best fit line, the way that you do this is you use the scatter plot that you've just created, and then you sketch a line. Now, the thing that you want to do with this line when you sketch it is you want to try to average this line so that there are the same number of points above and below the line. So that means if I have a line that looks something like this and I have like 6 points above the line like this, I want to make sure that I have about 6 points below the line. Now that line may not be perfect. So if that line's not real perfect, then all you have to do is just make sure that you have a line. That was probably a little bigger than it should have been. But I just want to have a line that I think follows the same kind of trend. So this one, again, might not be perfect. My drawing isn't as good as it could be drawn in this Mobi thing. But if we just pretend that this is a really thick line, maybe that's a little bit better. I've got 2 points that it's going through right here and here, and then I've got 3 points below and 4 points above, and they look to be pretty averagely spaced, and that's kind of what we're looking for here. The next thing that you want to do after you've sketched your line, you want to create an equation from this line. So pick 2 points that are actually on that line. They don't have to be original data points. If they are, that's great. If they're not original data points, then what you want to do is you want to make sure you find 2 points that you can use from your line. You're going to use those 2 points to create your own equation. That equation will then be used to determine whatever you need to determine. You can make predictions. You can guess what's going to happen at a certain time. You can actually guess something that's not even going to happen on your graph by plugging something into your equation. So that being said, let's look at one example that the book gave me. Okay. So here's a thing of scatter plots, or a thing of points. We're going to plot these points onto this scatter plot over here. And then what we're going to do is we're going to create a best fit line, and we're actually going to handwrite our way through creating one of these. And then I'm going to show you the same way to do it on a calculator, just like we did in class. Okay. So if we have fruit smoothies, these go from 1 to 10. So I'm just going to use 1 to 10. I'm going to skip lines though. So I'm going to use 1 here, 2 here, 3, 4, 5, 6, 7, 8, 9, 10. Now my line's not perfect, but it shows me what I need. Now these are in terms of dollars. So I think what I'm going to do is I'm going to try to do it every 4. So 25 cents, 50 cents, 75 cents, $1, 25, 50, 75, $2, 225, 250, 275, 3, 325, 350, 375, 4. And then that gets us to 5, and maybe there's one above 5 a little bit, and we can just kind of throw those up there if we need to. I'll try to move myself out of the way too, if I can. So move myself out of the way. So hopefully we can then throw that point there if we need to. Okay. This book example, again, since this doesn't come directly from your book, this is an extra example that I have. I just want to make sure that you understand. I want to make sure you understand how this works. So this is the question that would go along with it. It says the table shows the amount of fruit used to make a smoothie in ounces and the total cost in dollars of the smoothie. So this side over here, apparently my Mobi stopped working. I'm going to pause it just for a second. get this figured out. All right, we're back. So this side will show you the amount that you've used in ounces, and this side shows you how much you can charge for them. So the question says, does the data show a linear relationship? If so, write an equation of the line of fit and use it to estimate the total cost of a smoothie that is made using 8 ounces of fruit. So I'm going to go through and put these points onto this line. I'm going to make them a little bit thicker so that we can see them for sure. But I'm going to put these on this line so that way hopefully we can see them pretty well. So if I have one that costs 2 ounces of smoothie at $2.10, so 2 ounces of smoothie, I just realized that I put these on wrong. Give me 1 second, I'm going to clear this up. Okay, third time's a charm. Here we go. So now I've got it down to my x-axis is what it actually should be, and that's ounces of smoothies. My y-axis is the total cost, which is what it should be. So now I'm going to plot these points. So I know that I'm going to have a certain amount of ounces of smoothies and a total cost. So if I have 2 ounces of smoothie, then I know that that's going to be just a smidge more than $2 and a little less than $2.25. So that's going to be somewhere in there. 1 ounce of smoothie is at $1.50. So that's going to happen right at this line right here. I know I'm going to have 4 ounces at $3.05, so 4 ounces and a little bit more than 3, but we're not going to be able to see that much, so that's good enough. 7 ounces at $4.45, so 7 ounces at $4.45, a smidge less than $4.50. 10 ounces at $5.95, so 10 all the way over here and almost at $6. 3 ounces at $1.75. 6 ounces at $4. And 9 ounces at $5.35. So 9 ounces, a smidge more than $5.25 and like that. So now if we look at this, we can see the first question that it asked us is, does this data create a linear set? And I can see pretty closely that it makes pretty close to a linear set. If I create a line, because the next thing it asked me to do is create a best fit line. If I create a best fit line through here, it touches almost every point, right? So it touches almost every point that's on there. And if you notice, I've actually touched almost every point. Granted, these are a little bit inflated points, but that's okay. But you'll notice that I have almost every single thing, and notice that it has 1 point that's kind of above, 1 point that's kind of below. This is pretty close. So now what I'm going to do is I'm going to go through, and in a different color, I'm going to pick 2 points that show up on this graph. And I'm going to pick points that do not show up on my original graph. So here, I'm going to choose this, and that says 8 ounces. So 8 ounces of smoothie will be $5. So 8 ounces for $5. And then I'm going to pick another point, and I'm going to try to pick one that's kind of nice. So maybe like this one right here, where 3.5 ounces is $2.75. So I have one at 8 ounces for $5 and one at 3.5 ounces for $2.75. So that being said, what I'm going to do now is I'm going to create my line using y equals mx plus b. So now I'm going to use these to find my slope. So when I want my slope, I'm going to use m, and I'm going to do 5 minus 2.75 over 8 minus 3.5, and that's going to give me 2.25 over 4.5. Now, since I'm asked to just create a line, I'm going to use my calculator, and I'm actually going to simplify that so that way it's a little bit nicer for me. So 2.25 divided by 4.5 is going to give me 0.5. I guess I should have known that. Anyway, it's 0.5. And now I'm just going to plug one of these points in here to figure out my other slope, or my other, my b value. So it's going to be y equals 0.5 times x plus b. I don't know what b is, so I'm going to take one of these points. Let's choose the nicer one, 8 and 5. So it's going to be 5 equals 0.5 times 8 plus b. 0.5 times 8 is 4, so it's going to be 5 equals 4 plus b. So I'm going to get b equals 1. So my equation is going to be y equals 0.5x plus 1. Okay, so that gives me my a relatively good equation. Hopefully that's what I'm looking for. And now the question asks me to estimate the total cost of a smoothie using 8 ounces of fruit. And actually that was one of the things that we picked here. But if we wanted to check to see what happens with 8 ounces of fruit, I'm going to plug an 8 in here. 0.5 times 8 is 4, plus 1 is 5, so that tells me it's going to cost $5, which is what we just figured out, obviously. Now, just in case we don't have this, or just in case we don't have this tool, I guess, or you're too lazy or whatever it is, if you're too lazy to figure this out, or if you don't know how to figure it out, you can try to use it on your calculator and see what your calculator comes up with for you. Okay? A lot of the times, I'm way too lazy to get this done that way. I would rather do this on a calculator because the calculator does the work for me. So I'm going to go to these, the stat button. I'm going to arrow over to hit calc. I'm going to go up here and clear this out. And then I'm going to type in the same table that I just had. So it was 2, 1, 4, 7, 10, 3, 6, 9. And then I'm going to do the same thing in my L2 values, 2.1. If I've done oh, did I miss one? Nope, I'm good. Okay, so 9 and 5.35 go together. Now I'm going to hit the stat button again, arrow over, and I'm going to hit 4 for linear regression, and hopefully it will give me the equation of a best fit line that's relatively close. Now, we just had an equation that said y equals 0.5x plus 1. This one is saying y equals 0.51x plus 0.87. Pretty dang close. So either way, it's going to work for you. It's not going to change anything. Know how to do this with a calculator and without a calculator just in case. Okay, that's how best fit lines are going to work. Hopefully that's something you've done before. Hopefully that's something you've seen. The last thing I want to talk to you about is the correlation coefficient, because you might see this hanging out somewhere. The correlation coefficient is how tightly packed together values are on a scatter plot. So how close they are together. All of these are represented by the letter R, and the values go from -1 to +1. -1 to +1. So there are really 5 values that we're going to deal with. We're going to deal with -1, -0.5, 0, 0.5, and 1. And basically what this is saying is how tightly packed the points are. If you have a correlation coefficient of -1, that means the points are pretty close to a straight line going in the negative direction. If you have 0.5, it means they're a little bit more loosened up, but again, negative direction. If I see a correlation coefficient of 0, that means I can't tell what's happening. If I have a positive 0.5, it means that it's kind of the same as what was going on over here. And then if I have a positive correlation of 1, that means it's going to be a straight line going that way. Okay, so that's really about it for best fit lines in 1.3. So check Google Classroom. You'll see some homework on there. Give a few questions a shot. When you come back the next time, you're going to have a homework quiz. So be ready for a homework quiz. Be ready for a homework quiz without a calculator, because it's probably coming. Okay, this is going to be the first time I take your calculator away from you and make you do this without a calculator, because you need to be able to do this on your own. Okay, if you have any questions, don't hesitate to let me know, because I'm more than willing to help you out, whether that's via Remind, whether that's through email, through a phone call if it needs to be. Let me know, and I'm more than willing to help you. So if you have any questions, please don't hesitate to let me know. Good luck, and let me know if there's anything I need to help.